Okay, let's talk about electric work. Again, that's going to be work done by an electric charge. Now, our general equation for work is always going to be some type of force-like quantity. In other words, the reason things happen times what's being displaced. And we've already talked about it in terms of a fluid system, and we've talked about it in terms of a mechanical system. Now we're going to talk about an electrical system. Now, the force-like quantity that causes work to happen is a change in voltage. Now, we don't often have to write the delta. Sometimes we will just say voltage, because a 9-volt battery essentially means that if you have your 9-volt battery here, you have the positive part, you have the negative part. This is called the anode. This is called the cathode. And here's the key thing is when I connect those, there's a 9-volt difference. We just call it a 9-volt battery, but in reality it's because there's a difference in the two sides of the battery. Again, remember, negative part is the anode because it's got N in it. So your force-like quantity is the voltage difference between the two prongs of a battery, or the two prongs of an outlet, times displacement. Well, this is a new topic. That what's physically being moved in electrons is called electric charge, and we use the letter Q for it, lowercase q. It's electric charge. Now, this is a new unit. This is not something you've seen before. It's surprisingly enough not something we'll use directly even in the labs that we do. Now, electric charge is measured in it's the flow of electrons, but electrons are tiny. So what we've done is we've created a bigger unit called a coulomb, abbreviated with capital C. A coulomb. This is one of the 3 numbers you need to know for the class. 6.25 times 10 to the 18th electrons. That's how many electrons are in a coulomb. So 1 coulomb is equal to 6.25 times 10 to the 18th electrons. And that's unfortunately just a number you're going to have to memorize. There's no way around that. Now, the other way of thinking about this, 6.25 billion billions. That's a lot. So realize that's a very, very large number. So you think about that. So again, electric charge is measured in coulombs. Coulombs are the units with a capital C. Voltage breaks down to something else. A volt is actually a joule per coulomb. Joule is a unit of energy or work. And of course, coulomb is the amount of electric charge. So voltage is a combination of both of those. It's the energy per unit charge. Key thing to get out of this is the fact that energy and work have the same units. There's no difference. The only real difference is work is physically causing energy to be used and doing something. Energy can be used and not do any work. For example, when you push against a wall, you're not doing any work because the wall's not moving. You are actually using energy. You're going to get tired, but you're not actually doing any physical work. Our physical work means something has to be displaced. In the electrical world, what's being displaced is electrons, which is measured in a unit called a coulomb. So energy and work have the same units. So in the English system, it's going to be foot-pounds, because it's force times distance. And in the SI system, it's going to be newtons times meters. Now, newton times a meter is also called a joule. And we've encountered that already once, but we will continue to encounter that. Now, let's do a sample problem. Make sure that we can handle this from a math point of view, because you'll see some math with this. Let's say a 1.5 volt AA battery. moves 6 coulombs of charge. How much work is done? Well, find the relevant equation. W is equal to Q times V. You can write it as V times Q. I don't care. Remember, voltage is the force-like quantity. Q is the displacement-like quantity. So then I'm going to say 6 coulombs times 1.5 volts. Now, that's going to give me 9. But 9 what? Here's where we have to kind of make in the substitution for volts. A volt is a joule per coulomb. If I multiply joules over coulombs times coulombs, the coulombs cancel out and I'm left with joules. Or you could write 9 Newton meters. They'd give you the same thing. We have a lab that will involve this and hopefully get you ready and all that stuff. Hope you enjoyed it.